So welcome to today's webinar. Today I'm going to talk a little bit about indexes, how indexes are selected. We'll go into hopefully getting some understanding on why the runtime selects indexes and cases where it may not do what you think it does. A few of those. So my name's Peter Judge. I am a consultant at consulting work. I've been there for 3 years now, in fact, in the middle of July. Worked at Progress for a while before then, mainly an ABL guy, 4GL guy. Done a lot of PASOE stuff lately, and I'm sure I've met many of you at various PUGs, various Progress communities, other events. Consulting work is an IT consulting organization. We focus on OpenEdge. Mainly, and that includes programming side of things, PaaS side of things, and other related technologies. We have offices in Europe, in Cologne, in Romania, in the UK, and as well as the US. Customers around the world. I think we've got pretty much customers now in every populated continent, just about, except Asia. Our main lines of business are developer tools, consulting services, and we do a lot of modernization now with the move to OpenEdge 12 and PASOE. ABL, OpenEdge is a lot of what we do, but we have experience with many of the other tools, many of the other products in the Progress suite. Yes, so as well as kind of related things, a lot of DevOps, Jenkins build pipelines, those kinds of things, some Java, some .NET as well. So today, why do we care about indexes? Cover that. We're going to talk about how indexes are selected in a more simple fashion, but also more complicated, look at temp tables and some other gotchas, and work through that. So, why do we need indexes? They seem to cause a lot of pain, not pain, not problems, but they're confusing. But generally, they make the applications go faster in a couple of ways. One is that there's less work done on the database. So fewer records are read. It means less work for the database engine to do. And more importantly, in more modern kind of architectures, fewer records are sent to the client. So when I say the client, I don't mean a web client necessarily or a GUI client, but it's the ABL client that queries the database. So in a shared memory world, that's going to be the same host as the database server, and the records aren't really sent, they're just available through shared memory. But as soon as we go into the world of network database connections, now records have to be sent across the network from the database server to wherever that client is that is reading them. Right? So that's often going to be on a different machine. Sometimes it'll be on the same machine connecting through localhost, which is better. But generally, in those worlds, there is a network hop that's involved. If we select the right indexes, we read fewer records, we send fewer records, and then the client does ideally but usually less filtering and selection on the client. So it wastes less, if you will. And that's the main focus of doing this. Indexes also help us with uniqueness enforcement. So indexes can enforce uniqueness in records. So we have fewer records as well, but generally an enforcement mechanism. And lastly, depending on my audience, least or not least, but it makes for happier DBAs. When the DBAs don't have to deal with the database working so hard, they are generally happier people. We're not today going to talk about cases where we don't want to use an index. So a row ID find or a table scan or those kinds of things. Generally, we're going to look at, or generally, we're going to look at reading records from the database using an index. That's kind of the point of this. The other thing is, it's all cool, AI and vibe coding, the term, but one of the things that I find a lot, I think we see a lot in our customers, and generally, is people assume that the index is being used, that they think is being used. So, any index will do kind of approach, oh, look, there's an index in use. And that's great. An index is often better than no index, but many times you're not sure of which indexes are in use. And there's a couple of ways we can figure out what indexes are in use. For static queries, so a for or a find or an open query, compile with the xref option tells us exactly which index the compiler, the AVM, has selected for use, or indexes. There may be more for a particular query. For dynamic queries, that same information is available using the log manager. There's a query info log entry type. There's a query info log entry type, and that will give us that information in the log file. So on PAS, it would be in the agent log file, but also on any client. When you set up client log or a log manager log file name, we will see that information in there. And then there's other tools that read VSTs, like Protop is one, but that read VSTs and tell you what indexes are in use, or index usage statistics, which can also be useful. Yes, indeed. And just one more note on this. Most of the, well, I say most modern, certainly Progress Developer Studio, as well as the VS Code, the Riverside extension for Visual Studio Code, can automatically compile programs and do the xref for you. So you don't need to manually do it. There's a lot of tooling out there that helps you kind of get rid of the friction of at least producing this information, if not finding it. I discovered the Visual Studio Code in its latest pre-release actually has added some functionality that if you mouse over a buffer in a query, it will tell you which indexes are in use, which is great, right? And it's good, right? All queries will use an index, and so part of the question is it the right index? So that's the other piece to think about here when we're talking about verifying that you're using the indexes. So one is, am I using the index I thought I was using? And the second part is the index I'm using, is that the best index or the right index for the query we're trying to retrieve data for? And we'll take a look at an example a little later of, yeah, it's the right query based on the set of rules, but it may not be the best query based on what you're actually trying to achieve. So the log manager output for dynamic queries looks something like this. I've taken all of the stuff out of the left, which is the the timestamps and all of that sort of nonsense. But it shows us the query that was prepared. It shows us which indexes were used, and in this table there's a lot of records, or a fair number of records. How many DB reads were done? 180,000 or so. It's quite useful, or it can be quite useful as well, to show us how efficient the queries were. So in terms of how many indexes blocks were read, how many table blocks were read, and you can make an assessment of how efficient that index is. And that kind of can help you with, is this the best query for the job? This information is also produced for the static query. So if you just have for each order instead of a dynamic query with a query prepare string, the same information will be produced into the log manager. So you can see which queries, what the indexing on the queries is, can be very useful, especially in development, where you want to be sure of that sort of stuff, that you are using the indexes you think you are. Again, the more information you have about what indexes you're using, the better positioned you are to make a decision on whether that's the right one or not. Okay, so now we'll look at index selection. How does the runtime select indexes? So from the progress documentation, this used to be in what was called, was labeled an ABL web paper back in the 11 days, I believe, maybe even a little earlier. And now it's been brought into the formal documentation. There's a link down the bottom here, but you want to look for ABL trigger and database trigger and indexes. That's the search criteria, and that should get you to the right place. And it says the following, which basically, I won't read it out, but the compiler will look at a query, look at the where clauses, if there are any, and figure out from there which indexes to use. Index or indexes to use. And then it says the precise rules are numerous and complex, and it is not important to fully understand their details, which I think is, fair in a sense, because you cannot change. You can only influence the compiler to use a particular index, or persuade it maybe. But it is good for us to understand the rules, why they do the things we do, why they select the indexes they do, and also why, for instance, moving from a find to a find to a for each can change things. So before we get to the rules, there's kind of the actual rules themselves and how they're implemented. So the first important thing is we're just talking about ABL here. The ABL, the compiler selects the index or the indexes to use, and those are the ones that are used, not the database engine. That's different from SQL, how it works, which uses a cost-based optimizer to select its indexes, of the indexes. In ABL, the rules are applied in a particular order, and they're applied hierarchically. And each rule is applied, and basically the number of indexes that are going to be used or can be used is whittled down by kind of a process of elimination. And so we'll work through a little bit of that. Some years ago, I did a similar presentation with Paul Kafars from White Star, and we found that putting a worksheet approach together is a good visual guide to working your way through how the rules are applied. You can, of course, just look at the rules and say, look at the compiler output and say, picking this rule, but understanding why it selects a rule is sometimes very useful. There's a set of rules. The first set only apply to a subset of indexes, and how it selects the indexes is the compiler will look at all the fields in the query, select all the indexes at first that have leading components with those fields, and that's very important. So I'll talk here, I'll try to make it as clear as possible when I'm talking about fields in the query versus fields in the index, because they're the same but different. They have slightly different aspects to them. So the important part here is that in order to use an index, you have to select the leading fields of the index. So if we have a query like below, customer where state is Leinster, city is Dublin, and we have an index called srep state city, right, with state and city fields in them. For this query, this index will not be selected because the index selection happens on the order of the fields in the index. So just because state and city are in an index doesn't mean that the index will be used. If we had sales rep in this query, then we would start out with 1, 2, 3 indexes to choose, or to choose from. So that's really important to know. That just because a field in the query is a field in the index doesn't mean the index will be used. It must work in leading order, so from first to nth. There are some tools as well that are not documented here. There's some undocumented ZQL, which writes data to the database log file, which is why I haven't put it in here. But that can tell you how many fields, how deep into the index each of these queries go. That may be useful as well as a diagnostic tool. But generally, knowing which index you're using and understanding whether it's the right index or not is the first most important thing. The other thing to note here is that the order of the fields in the query are unimportant. So in this for each, we have state is Leinster, sales rep is some value. So the field order in the query is state, then sales rep, but the order of the fields in the index are sales rep, then state. And because sales rep and state are both in the where clause, and sales rep is the leading index, the leading field in the index, this index is a candidate for selection. Sales rep not, those not, but sales rep and state, those two are. Sales rep, this index is as well a candidate for selection because it's got sales rep and state in it. Okay, that's an important thing to remember. That's an important thing when people, start coding their queries and they just want to search on these things and they wonder why things are going slowly. All right. So the rules as documented basically we'll start with the selection. I've mentioned this a couple of times with indexes where the leading components in the index are in the where clause. Firstly, if the where clause uses the contains statement or the contains operator, we'll use the word index. The next rule is look for a unique index where all the components are involved in the equality matches. So all of the components in the index are involved in equality matches. Then we move on to most active equality matches. So equality being equals operators. Most active range matches. So talking about greater than and equal to's, greater thans, or greater than equals to's. And then most active sort matches. So in your by clause. If multiples remain, then the additional criteria, there is no rule 7, is that if the primary index is still available for selection, use that. Otherwise, pick index alphabetically by name of the remaining indexes that are available for selection. Okay. So there's a couple of shortcuts, and this is part of the numerous and complex. Basically, if there are indexes that select supersets of other indexes, then we will eliminate those, right? The purpose of using an index again is to retrieve the smallest number of records from the database, from storage. And secondly, if there's a by clause and there's an index with the field in the by clause that is in an index that is candidate for selection, we ignore, or not we, the runtime ignores the sort. And that's because indexes will naturally sort records, right? That's kind of how they work. So sometimes we won't select, or we won't see the by clause playing an active role in selection of an index. Okay, so with that, we're going to kind of go through some examples of how indexes would be selected. So we've got a order table here. It's a modified Sports 2000. The top 4 field, the top 5 indexes are from the Sports 2000 table, and we've added a couple of extras here for just examples. You'll see, for instance, sales rep and order date have got the same 2 fields as order date and sales rep. That is not what I would do in a real database. There's no real purpose for doing that, but for illustrative purposes, we have that in here. Okay, so onto our kind of worksheet, right? So the rules on the left here, I've kind of got this dotted line, which is the first 6 are the kind of hard workers. The last 2 are just tie breaks, really. Index is on the top, unique, cust order. The fields are pretty much in the index name, so we should be able to figure that out. Primary, unique, and a word index. So for each order, there's no where clause. We're going to select all 8 or 8 of the 9 indexes. Right? The word index will not be a candidate because there's no where clause, there's no contains. Complete index. Is there a unique index found? There are no where clauses, so we go all the way down to the bottom, and the primary index is selected because there's no where clause. Right? Fairly simple. If we now look at a query where we have something like where sales rep is BBB, we initially look at which indexes have got sales rep as a leading field, and that's our sales rep date and our sales rep indexes, right? There's no contains, so that doesn't select. Neither of these are unique indexes, so that doesn't select, and we get selected by the third rule, which is the most active equality matches. So we'll get on this a little bit later about what most really means. But for now, the sales rep index is picked from that. Looking at a different one with more components, we have a sales query where sales rep is a value and order date equals something. So what are all the indexes we can select? Right, so the ones beginning with sales rep are going to be sales rep date. The ones beginning with order date are going to be the order date index and the date srep index. So there's no contains, there's no unique indexes in there. The most active equality matches, the srep date and the date srep have got 2, right? Both of the fields are, so 2 is greater than 1, which would be the sales rep or the order date, and there's no further selection that happens. And so which one does the compiler choose? It says, is one of those indexes the primary index? No. So then go by date. Go by alphabetical order. So the name of the index, date srep, is selected. Similarly, if we put a by clause on there, the same criteria happens. Note that the sort doesn't kick in, right? We don't do the sort selection because it's already sorted by one of these indexes, right? The sorting is already happening, and again, we'll pick the date srep index. Values by the sales rep values are sorted already. I mean, in this case, it's an equality, so they're all going to be DKP, but that would be why it doesn't pick them. Moving on to an additional index or additional searches, right? So sales rep is BBB, order status is shipped. There are 3 potentials. SREP date because it starts with sales rep. There's no unique indexes in these selection criteria. And so we look at which have got the most active equality matches, and that's going to be sales rep has got 1, sales rep index, and the order status has got 1 as well. And so we use 2 indexes, or the compiler uses 2 indexes in this case to do the search. Okay, there's no further selection that needs to happen. We have some range matches where sales rep is greater than or equal to DKP, order date is greater than a date value. Again, leading components, no unique indexes, there's no word indexes. There's no equality matches in here, right? These are range matches. And so we do the search here. Both indexes, again, this is very similar to the equality search. Our candidates, when they hit the bottom of our kind of first 6, and we'll pick the first one by name, which is our friend date srep again. If we now look at the sales rep and order date by sales rep, so a similar query but with a query criteria, with a sort on it, it's going to find the most active the most active range matches, and it's going to use the sort in this case to do the selection, I believe. The sales rep index is the one that's used, and the sales rep sort will pick that. Okay, on to picking an order date. And this is where it starts to become what we would expect from here, where order date is something like this. The date srep and the order date, it selects the 2 and selects them by name. And this is where the most active equality matches becomes interesting. We have order date, which has got one field out of one index field. We have date srep, which has the leading field, but not the second field, right? So the equality is on there. And in this case, we select by alphabetical, not by order date, which is a little unusual. Excuse me. Something similar happens here. Again, order date and ship date. So order date, we pick the 3 because the date and the ship date, the order date, and the order date indexes, they all have leading components of one of those two fields. They're not unique, but the compiler here will pick the order date index, not the ship date index, because I think in this case it's 1 out of 1, not 1 out of 2, which this is a 1 out of 2, this is a 1 out of 2 as well. And kind of you can infer that, because if it was each of these indexes have one active equality match, but these two don't. But the date srep is not picked, which I would think would be the case if we went all the way through and picked by name. So this is where assumptions or where you really need to verify not just that the index you think is being used, but that it's the right index for what you want to do. For example, so in the general rules, in the documentation, it states use the index with the most active equality matches. Equality matches are active if both conditions are met, and they are joined by ands that we saw. They apply to successive leading index components that we saw. So in both of these, in this case over here, the previous case, all three of these indexes have got one, and I suppose it's maybe how we read the word active, but there's one active field. Oops, sorry, go the other way. So that it seems like almost the percentage of fields in the index I've used are also part of the most piece of it, right? So one index field used out of one field in the index is a stronger match than one index field out of the two in the index. Again, validate the index that's getting used. And where this can play a role is if we have a query something like this, right? So this is a parent-child relation, right? This is a query that may get built for each order line of order, not of, but where order num is that and item num is that, right? So in this case, we really want to filter to return the number of records for that order, and then subsequently filter by item num, or we want to use two indexes for doing this. However, in this case, the item num index is used. Okay, and that's going to be because it's 1 out of 1, right? So the selection here would be the order line index or the item num index would be used. The unique fields doesn't count, or the unique criteria doesn't count because line num is not part of our query. So this is a 1 out of 1 equality match and a 1 out of 2 equality match. And the item num is getting used here. So in an application, you can easily see that order 42 is going to have, even if it's got 1,000 order lines, right? Whatever the number might be, that's 1,000 that you've got to select out and get the ones that are item num 11. Whereas the number of order lines with item num 11 are going to be vastly bigger. And so in cases like this, what's going to happen is you are going to have to, not you're going to have to, but the client is going to get all of those item num, all of those order lines where item num is 11, and is going to have to filter them on the client, which is bringing potentially a large amount of data back to the client. So in this case, an item num index is being used. That's fantastic. Is that the right index? It's been selected correctly. Is it the index we want to use? Yeah, not really. I mean, we'd almost rather have it forced to use order num and then do the sorting between those 1,000 order lines to pull out the ones with item 11 rather than pull out the 100,000 item order lines with item number 11 and sort by the number 42 or select for number 42. So that's cases where you really need to be careful about which indexes you wanted to pick or you think has been picked. Yeah. So I mean, ways to mitigate this. One is the use index statement. So you say, I'm going to force you to use the order line index, which is the primary unique index. That's a way of doing it. However, use index has its own problems. Right, we'll get to that in a sec. Use index has its own problems. Another alternative might be now you've got an add index on the order line table on order num, so that the compiler can choose two indexes, right? A single field index with just the order num field in it, so that the AVM can now choose the correct indexes. So it'll choose two indexes because they both have 1 out of 1 equality matches, and so the right thing is used. So again, I keep coming back to this, but verifying that it's an index you think should be used and making sure that the index usage is important in terms of what it is you want to do and what the shape of the data looks like for that, right? So developers should really have an idea of how many records, more or less, is this query going to bring me back if I use this index? And as I say, this becomes more and more and more important as people are moving to PAS. Generally, one of the selling points, one of the value propositions of PAS is that you can scale them horizontally. If you do that, you are going to have network database connections. You are going to have to deal with moving data from the database server to the PAS instances. And that's where this becomes really critical. There's a lot you can tune. There's a lot of stuff you can do in terms of network messaging parameters and things, but the crux of how much data, you can move a lot of data through a large pipe, but you can also move almost no data through a large pipe even faster. So making sure that the index selection that you use matches what you think the shape of the data is and what it looks like, what you think that's going to look like. Okay. Breaking index selection, that's also easy enough to do. Any expression, there's a couple 3, will break bracketing, break index selection. So even if order date is a field in the index, using the month statement is not going to select an index. There's a row ID function that does not use an index, but that does not break indexes, but that doesn't actually use an index. There's a row state function on temp tables that are in a data set that has its own super secret hidden index, but that uses an index. But any other statement, if then else is in query, to try and pick fields, they're all going to break your query selection, or they're all going to be ignored for query selection more accurately. If you're using if then else's to build up a where string, it's far better to use a dynamic query. It doesn't have to be is to use a query rather than a for each, right? It doesn't have to be a dynamic query. You can build a static query on the fly far easier than you can, right? Than putting if then else's into your where clauses, which will break your indexes. Begins is nice because it is basically considered a range, right? Greater than equal to, almost. You could think of it as a greater than equal to. Matches, on the other hand, does not break, does not do anything. It breaks bracketing. And again, you can see this by the indexes that are selected. As I said, generally it's enough to see what index name is, and you'll be like, hang on, I wasn't expecting to use that one. Why is it using that index? Okay, so now we'll look at the impact of OR statements in the where clauses. So we'll look at the customer table here. Again, it's a modified custom table from the Sports 2000 database. You may be familiar with these indexes. Some of them are somewhat duplicated. But basically, this is the main extension, the sales rep country credit limit index. So for a query like this, for each customer where name is Acme and or sales rep is B, which indexes do you think would be used here? Right. So I can see the name, I can see the sales rep, and both of them are used. In the output of the XREFs and in all the other outputs that produce index stats, you will see both index names in there, right? In the XREFs, we look for the search statement or the search keyword, the search identifier, I'm not quite sure what that's called, database.table name, and the index name appears afterwards. So now we know we're using two indexes. That's great. Another example, where name is Acme or name is Roadrunner, which indexes are going to be used? Well, we're fairly sure the name index is going to be used, and of course it is. But what's useful here is it's used twice. Right? So there's one bracket on Acme Inc., which I misspelled, and there's one on Run Roads. And both of those indexes will be used, and those two records will then be returned. Right? So both indexes are used in that case. OR makes a massive difference to how the AVM selects the indexes. So you can think of it as each side of an OR goes through that whole worksheet process, that whole index selection process works through index selection on the first part of the OR. Then following the OR, it breaks it down, okay, what does the where clause look like until you hit the next OR? We looked at this, right? Two distinct index operations. There's a selection criteria for name equals Acme. There's a separate one for name equals sales rep equals BBB, or name is Acme, name is BB is Run Roads. Two distinct index selection operations, and that goes down until we hit an AND. Parentheses can serve a purpose like that as well. They can also force a logic tree to be built. So if we kind of visualize that with our worksheet, we kind of have those two operations that both work, and both of those indexes are used, and the data is returned based on that index selection. Okay. Taking a look at this example, that's really, okay, I clearly left out the index name here. For each customer where name is Acme or name equals Run, and this should say use index, I'll go to the next slide because I put it in there, use index name. Okay. It's obviously going to use the name index, but because we said use index, it's only going to use one index. Or it's only going to use the name index once, more accurately. I'm not entirely sure which of those two records it would find using the index and which of the two records it would find using the client-side selection, but the point is that it uses one. This is documented in the bowels of the use index statement, but it's not immediately obvious. This came up in a post on Progress Communities a couple of weeks ago, which is why I kind of included it in here. I believe it was Carl Beast who made a comment to this effect that was like, hang on a sec, why is only one index being used when I expect two? So this is kind of an example, I suppose, in reverse of if you move from, if you modify your for eaches and you choose use index, or you remove use index, right? It's generally good practice not to have use index on a for each. There are reasons to do it, but generally not. How things may change. In this case, removing the use index statement will change for the better because two indexes will be used to select the data rather than just a single instance, if you will, of the name index. So that's again consequential of making changes to where clauses. Okay. Yeah. So just working through, I've broken down my query, simplified it a bit. Don't look too much at the names or the values coming back, right? That's just an illustrative purposes, but how many kind of simple where clauses do you think are here? Bearing in mind we've got ors, so I would expect to see a couple, right? There's one or there, there's another or there, that's an and there's another or there. And so when we break that down, when we do the query, we can see that we have an index on name, we have an index on country. This one is a sneaky one. It's 2 indexes on country and name, and then this is on sales rep. I'm a little surprised this doesn't use sales rep twice, but it uses sales rep once. So we've built the query down like that. So, and again, validation that it is using the indexes, and this is how you can persuade the compiler to use an index, or to use more than one index, or to use indexes a little better, is by grouping your query criteria into groups, I guess, with OR strings. The results, if you turn all of this into if statements, right? If you just say, I just want to get customer name equals Acme Inc. and then filter by country later, is fine, but what it means is you have to do the sorting on the client, right? And again, one of the goals of using indexes effectively is to make sure that the database server does all of the work, or as much of the work as possible when selecting data. Other things, obviously, that one could do in a case like this would be just to look at customers and countries and be like, okay, how many countries are there? 180 odd, right, at most. How many customers are there? Well, hopefully millions, but hundreds of thousands maybe. So this search criteria this query might be better rewritten to be for each country, where country is AAA or DEN, and then join the customer table to that where customer country is the country.country and the name is whatever, and break down the query like that. So there's ways of, if the queries get too gnarly, there's definitely value in evaluating what are they actually trying to do, and can you invert the order of the query by searching a table with smaller records, or fewer records, not smaller. Fewer records is the important thing, not smaller, and then join to the larger table, so that you can take use of better indexes or more indexes on, or more precise indexes, if you will, on the bigger table. In this case, very similar. Acme is OR, Acme is country is AA, or customer name is Acme Inc., and we've got the same where clause. And in this case, we're going to use fewer, because we have added an AND. So the evaluation moves down the tree until it hits an AND. So there's one logic tree, there's another logic tree, here comes the next logic tree. Oh, it hit an AND. Okay, so now I'm going to evaluate everything in these parentheses as one logic tree. Similarly, in the bottom is an OR as well. So the evaluation varies, and the ANDs are really the things that should key you. And you've got more complex queries like this, make sure that you make doubly sure that it's using the indexes you expect, and even more importantly, the number of indexes you think it's going to use. All right, but wait, there's more. So indexes and unknown values, right? One of the reasons to have an index is to enforce, or have a unique index is to enforce a constraint, so that you have one value per that index field. Which works really nicely, except for that little pesky unknown value in ABL. So adding, if we have an index over here that's unique on custom, we can add one with a custom of 1, we can add one with a custom of 2. If we try to add a third record with a custom of 2 again, the database or the language would throw an error and say, hey, this record already exists with this unique index. However, we can add any number of unknown value records on a unique index. So that is something to be aware of. It's something I think is relatively commonly used. So people will create most of a record, put the unknown value in it just to get it into the database, and then calculate that unique value afterwards. So in theory, there's at most only ever one value with an unknown value, one record with an unknown value in the unique index. That's the theory. It doesn't always work like that in practice. To get truly unique values, you need to mark the fields in the index as mandatory. So then the unknown values will not be allowed. When sorting, the unknown values will sort higher. So higher as in has a greater value. An example, Mary sorts the unknown value. If we do them ascending, it would be Peter, Paul, and Mary, as opposed to Mary, Paul, and Peter. A thing to know. Indexes and case sensitivity. Generally speaking, the index field values are stored as uppercase values in the indexes. I mean, in the database. Sorry, in the records, they'll be stored as you pass them in. And yeah, in general terms, in general terms, right, for unique fields. So in unique fields, Paul is equal to Paul, all caps is equal to Paul, all lowercase equals to Paul, in any variation on that theme. With case-sensitive fields, then the index field values are stored as entered, and obviously the data fields or the data values are stored as entered as well. If you sort on case-sensitive fields, then that may differ depending on your collation tables. And word index fields are always treated as case insensitive values. Okay, so temp tables. Temp tables are fun in the sense that they're almost but not quite like database tables. So in a temp table, our first alphabetical rule gets replaced by the first defined rule. So the index is obviously defined in a particular order in code. And if we get to a tie-break situation and the unique index or the primary index is not available for selection, it will be which of those 2, 3, whatever indexes are first defined in the temp table. The other thing is you cannot mark index fields as mandatory in temp table indexes, and so you have to guarantee the uniqueness in application code. So that is a difference, an important difference, and especially if you are building business entities, business services that use temp tables and then commit them to the database. If you want to make sure that the business logic, the business entity enforces mandatory values, you're going to have to write the code yourself rather than depending on the compiler or depending on the runtime to tell you. We've touched on this a number of times through here. The ABL compiler doesn't know how much data there is in the database, right? Which kind of is one reason why why we are able to compile applications with just an empty schema. So it doesn't know how much data is in the database. It doesn't know the distribution of that data across the tables you're querying. So it cannot do the cost-based optimization that, for instance, the SQL engine does. And so with that in mind, as I said, the developer, as you're building your queries, as you're building your code, as you're writing your code, as you're testing your code, you should really understand, and I appreciate that not everyone or very few people will have development environments with the amount of data that's sitting in the UAT environment or your testing environment or your training environment and even in your production environment. But as a developer, you really should understand, have an appreciation for how that data is distributed, right? So in our example about order lines and the item num being selected, that may look good, but why it doesn't look good is when you understand, when you have an idea that there are significantly more order lines with an item num than there are order lines with an order num. And again, just because you're using the index you think you are doesn't necessarily make that go as quickly as possible. Inverting the query may go faster, so flipping things around, querying smaller tables and then larger tables. There's techniques I've seen people used as well, using joining a large table to a temp table that has got the filter criteria in it, because then the joins are obviously the temp table is all local. That doesn't go on the database server, but the joins that are then made to the large table can be done more efficiently. I've failed to mention, I think, in this. So I've talked a lot about, well, particularly with the ORs, as well as with the, in certain circumstances, with the ANDs, where multiple indexes are selected. My assumption or my examples here have always talked about fors, pre-selects will do the same, for each is pre-select each. Using the find statement will select an index, but it cannot select more than one index. So generally that is something to be aware of if you're doing a find first. I know there are people who are vehemently against the concept of find first, but doing a find statement with complex where clauses will only ever use one index for that query. You'll see the index in the xref output in the log manager, but the assumption may be that I'm using multiple indexes on those finds.
Yeah, there was a kind of related question where, in the case where I have where sales rep equals BBB and order status equals shipped, whether it's better to use two indexes, one for order status and one for sales rep, or have one combined one.
That's a great question. Sorry, I'm just going to skip forward. Generally more smaller indexes, I think, are a better approach. Generally, it does depend. It does depend on what kind of queries you do. Duplicate index. So again, the example with the order line with the index that's order num and line num, right? A solution for that would be to say, yeah, let's add another index to just on the order num. So now you've got a uniqueness constraint plus you've got a selection index, right? Both of the same fields. So there are reasons to have multiple field indexes, not necessarily related to index selection, right? The uniqueness thing in particular, mandatory stuff in particular. But I would say generally more indexes for search criteria, and I'm putting all of the DBAing aside of storage and space, are going to be better. The more indexes there are, the relatively slower data creation, data updates become, because not only does the data record get written, but the indexes need to get updated. So all the indexes need to get updated. So if you have multiple indexes, that's more update time. But here we're talking about retrieval, and in the retrieval case, more indexes, I'll just wave my hands, the more smaller indexes are going to be better candidates for being combined together. So you've got a better chance of the compiler, or you're more likely to have the compiler use multiple indexes even within a logic tree. Hopefully that answers the question. Yeah, I mean, this is still my favorite staying, so I'll keep putting it on top here. Understanding why an index is selection is very important. As I've mentioned, there are various subtleties in terms of sometimes how things are selected. Sometimes the documentation is it's not misleading, it's a little vague. Sometimes behavior looks slightly different. And so with that, you really need to, you really should validate that, right? Putting a compiler xref into a build environment is a great idea. If you use PCT, generating xrefs out of your build is trivial. You'd have to write something to grep out the indexes that are in use, but it ties them back really nicely, right? The xref output, line 47, there's the index, right? And have reviews of that. Log Manager is another way, and there's an index information method on a query handle that will also tell you at runtime if you don't want to log stuff out. I did forget to mention that. But you can look on a query to see which indexes are being used. On a dynamic query, it will tell you what indexes are used. And fortunately for us in AVL, there's no real difference between static and dynamic. So you could have a static query and query the index information dynamically there at runtime. A lot of the information I've talked about here, the rules, there's other useful information on this documentation page. It's now, as I said, in the formal documentation. Has information about using things like whole index, when you want to, if you want to, versus table scans, which is another way of optimizing data retrieval that, in this case, bypasses indexes. So that's good to look at there. We always put our conference slide up. There's a couple of conferences still left this year. The two biggies at the end, towards the end of the year, coming up quite soon. The Pug Challenge in Boston at the end of September. It's going to be in Westford again this year. Going back to Westford, hasn't been there for a while. And in November, the Pug Challenge in Valencia. And for those that are in South Africa, or the Southern Africa maybe even, there's a Pug Challenge at the beginning of September in Johannesburg and Cape Town, if anyone is any interest. With that, I will move on to questions. I am pretty much on or out of time. I will just put one more slide up. And so you can find these videos within a week or so. Should be up on the Consulting Work YouTube channel. You can go rewatch them. And share them with people. So with that, Marco, are there any additional questions or any other questions?
Was asked. I would give it another.
Give it a minute.
Maybe a minute.
Sure. Gladly.
It doesn't seem like anyone's jumping in.
Okay. Well then.
Oh. Can we go back your most equality slide at the beginning? How does a for first use index selection?
So back to my, where's the slides? See all slides. Back to
for first.
Back to this slide. So a for first, for each.
22 was.
22. Yeah, see all slides. 22. Back to this one. This is 22. Or the next one.
This one.
This one. So the for could be a for each. It could be a for first. Could be a for last. Could be a for without any qualifier, which is effectively the only four unique, more or less. Um, all of those will use the same set of index rules. So if you do for customer where sales rep is BBB, you're probably going to get an index. You're going to get one record. You're not going to get a not available or a violation. For first, we'll bring the first customer, right? It will use the same index criteria. So if we do for first, that one,
Maybe
something like, not that one.
maybe as a hint, you said it selects sales rep because of most equalities.
Yes.
One slide before or after, it selected both of indexes with nearly the same case.
So in this case over here, this is where it selected both.
Yeah.
Yeah. So they both have the most equality matches in here. And again, this is my supposition on. This is one index field, sales order status, out of the one field in the index, right? So query field is one and index field is one. So it's one out of one. In this one, it's sales rep is the query field one, and there's one index field, so one out of one. In this one over here, query field is one, but there's two fields in the index. And so those indexes are selected because most, I believe, means most of the fields in the index rather than absolute number of matches. Was that the question?
Yeah, I think that was answering the question.
And again, this is slightly confusing because sometimes it's slightly confusing because sometimes it doesn't do what you think it's going to do.
What is the easiest way to check for that?
So you cannot determine why an index is selected. There's no real way of knowing why an index was selected. Progress doesn't provide any insight into that. But what they do, as I said, what they do provide is the XREF. So on at least one of these slides, see all slides. So for instance, on something like this slide here, the XREF tells you customer name and sales rep. So in that particular case, it would show you, I don't think I can show you my screen. Which was that one again on slide 22 was, it wasn't that one, it was this one here. Sales rep is BBB and order status. So let me see if I can get that. Order status and sales rep. Where's that? I have. Where's my sharing gone? I'm going to share my screen. If I can find YouTube, not YouTube. What are you called? Sorry, I'm just trying to share my screen properly because I can. But now I can't find. Go to. There we go. Go to. I'm sorry. That's me. There we go. There it is.
Yeah, it doesn't work.
That was sales rep and order status. That was line 28. Yeah, so I'm not going to mess around. Sorry, with go to. Exactly. But yeah, so there's an and it can select the two. It will select the two queries if it can.
Okay.
I'll validate that. I'll put a post up or a comment.
Yeah, if there are any more questions, I would say
questions
on the slides. So please get in touch with us.
Yeah. So email up front. Are there other questions, Marco?
No, that's it.
That's it. Okay, awesome. Well, then thanks everyone for attending. Hopefully it was useful and interesting. And as Marco says, if you have questions, feel free to email us, either at my email address or info@consultingback.com. And we'll look forward to seeing you on the next one of these. Have a great day. Thank you.